Asia Pacific Wi-Fi Design Deep Dive. I am so excited for today's webinar that I am wearing my I Will Never Design a Bad Wi-Fi shirt, of course. So, of course, today we'll talk about bunch of exciting things about the best practices on Wi-Fi design. And the best part is, of course, we'll get to hear it from Stu and Troy, our best of the best presenters for Ekahau. So Stu and Troy is our host for today. So Stu is the global director of community and customer engagement. You know him. If you don't know him, I'm not sure. I'm pretty sure you know him. And of course, we have joining us today is Troy Martin, our director of product marketing and ECSE. And of course, I forgot to introduce myself, but I think most of you know me. I'm Anna. I'm the sales engineer for Ekahau Asia Pacific. And then, yes, I think I'll give the floor to Stu and Troy. Take it away.
All right, thank you very much, Anna, and welcome everyone. I'm joining you today from Ottawa, so on the other side of the capital of Canada, actually this evening. It's actually early morning, so it's 1:36 a.m. for me, and I think in Singapore it's probably 1:36 p.m. So isn't that cool? On the other side. But in any event, as was introducing Troy, for those who don't know, Troy has recently joined us here at Ekahau, and he's heading up heading up all that cool that training and all the marketing product marketing side of the things. So great to kind of get started. So, but before we get started today, and I had a slide for that. Isn't that amazing? And before we get started today, we want to kind of I wanted to kind of let you know that we do have this cool environment that we actually started a little while ago, and it's called the Ekahau Public Slack channel. And what this is it gives you a chance to kind of join in. You'll see your peers. There's well over about almost yeah, close to 1,300 of you actually in there, and people from all around the world. And where you get to go in, ask them questions about Ekahau, understand maybe some cool questions you may have forgotten to ask on the webinar. Go drop them in there. Introduce yourself and kind of network with your peers. So it's a great avenue for that. So if you've got a chance, go over there. And I think Anna's going to put a link in the chat there for us so that you guys can take a look at that as soon as I move the slide along here. All right.
Yeah, so it's a
Now, what we're
fantastic resource. Like it's a way to
Yes.
crowdsource insights, bounce ideas off peers. If you're working in a particular
Mm.
deployment or a challenge in terms of surveying or thinking through a design, it's a great way to get answers and different perspectives from other people that have been in the same spot. So definitely sign up for that Ekahau Public Slack. Reach out, introduce yourselves, ask questions, become active on the community, right? The more you participate, the more value you'll get out of that.
Yeah, absolutely. Great point, right? It's a great point for sure. All right. So while we're here today, is Ekahau AI Pro Online. Now, this is a new tool that we launched. When did we launch this? A couple months back or a little bit longer, Troy? I think we've kind of
Yeah.
went full on. Yeah. And we've been developing a lot of new feature sets in here. And so today we're going to cover a lot of the cool things that we're doing in the online version. Now, of course, with any kind of with when you're designing networks today, one of the things is, there's a number of different ways to look at, an account project heat maps, right? So how many different ways can you do this? Well, we have a number of different ways. So when we look at heat maps today, there's a number of things that we can take into consideration. We have our simulated, right? This is where kind of our best guess effort from using the software. We've got our where it falls into kind of that new network design. So when you're simulating new network design, new APs, greenfield, and can be brownfield, right? And that means that there's currently an infrastructure in place. That's a traditional predictive modeling, and you're using, and we'll show you a little bit about that in a moment. Of course, you got your measured simulation. This is when you're grabbing some actual empirical data, like from your Sidekick 2, right? And understand what the existing network looks like so that you can redesign it and use measured data to model that. And of course, there's the existing network redesign analysis with some live heat maps and using your Sidekick 2 as well. And of course, there's just measure only, to understand from a network analysis, right? Understanding what's happening in the environment. So with kind of from an AI Pro Online perspective, we're going to cover a little bit about what some of the heat maps are that we got today. Now we've got two views that you can actually take advantage of within AI Pro Online. Well, one is the traditional 2D view, which is super cool. It's got that flat view and the more traditional, what you've always become accustomed to. And then we've got our 3D view, which is even super cool, right? Where now we can look at attenuation zones. We can look at the height of objects within that area, and then the placement of those APs, and then kind of pan around. And we'll dive into that as well. Now, here's some of the kind of the new heat maps that, or get accustomed to some of the heat map visualizations that you'll see within AI Pro Online. Now, of course, it's our standard signal strength. This is where we're going to see how our APs are performing from, either in a simulated environment, what are the obstacles and what it's going to look like. And you can even single those out by clicking on each individual access point. It shows you individually how each one is performing. You got your ever so popular secondary signal strength, which we'll talk a little bit later in our inspection. But this plays a key important role in roaming, right? This plays of how we make sure that we can actually pass along to the next access point. And our ever so popular SNR, which is our signal to noise ratio, and then our channel interference visualization. So these are kind of some of the key core heat maps that we've got available. But Troy, I think we've got a couple, some even more in-depth ones here.
Yeah, so we've added a few more visualizations to AI Pro Online. We've added a dominant AP visualization, right? And we'll show you this, what this looks like in a demo. But the high level concept here is that when you flip to this view, it'll show you roughly the coverage that you'd expect to receive from a particular access point, right? In each AP, its sort of coverage area would be represented by different colors, which also ties into the co-channel interference view, where you can see if there's too many APs that are lit up with the same colors, that could suggest that you have a co-channel interference issue. But it also shows you approximately the point when you may expect to roam from one access point to another. And that ties into another inspect feature that we'll show you a little bit later in the webinar. We've also added the capacity visualization, which is super critical to designing modern Wi-Fi networks. It's one of the key considerations you should be looking at in order to deliver on the performance goals and targets for your wireless network. Now, there's a few different ways to look at it, and we'll dive again deeper into these. But just to put some earmarks or sins in the wall there, you can look at capacity in terms of overall throughput from a client device perspective, and you can also look at it from a number of client devices per radio, right? And so we can look at all that information there. And a couple of views that I find management or layer 8 are always very keen, very excited to look at. Things like data rate, right? This is the data rate or the speeds and feeds as advertised by the access point when you're putting together a predictive or a simulated design. And if you happen to be on site doing a survey, that data rate is what you're actually seeing from the access point. Now, keep in mind, these are more the theoretical data rates. When we start actually pushing traffic due to the half duplex nature of Wi-Fi, we'll see a significant reduction in the data rate value, something much closer to throughput. So things to keep in mind when you're preparing a predictive design or a simulation, that throughput view is the calculated throughput that the APs are capable of offering to client devices. Now, depending on what the actual client devices are capable of supporting, you may or may not actually experience those throughput values, right? If you have a really old or legacy 2.4 11N device, its maximum data rate may be 72 megabits per second, even though you're connecting to an AP that's capable of 1200 megabits per second for a data rate. And if you were to run a speed test, you might only get 35 megs of throughput at a particular spot on the floor. Now, if that manager or, project management person happened to step out into the hallway to run that speed test and they say or report back that they only generated a throughput test of 35 megs, they're quite upset because that data rate visualization showed them 1200 megabits per second. Now you can explain to them what the difference is between data rate and throughput and why it matters quite a bit which device you're using to generate your traffic, right? So all of these visualizations taken from an aggregate perspective gives you a lot of insight and the ability to analyze the efficacy of your design and whether or not your network's operating, your wireless network's operating in a healthy, efficient, and optimized state, right? So each one of these heat maps on its own doesn't tell you the full story, but as you start stacking them together, you get more and more insight in how they relate to one another.
Yeah, I mean that's a great point because when we get into kind of understanding those visualizations and how as as we kind of segue into kind of the tool of that predictive modelings, how does the when we look at the coverage, how do the I guess the objects play a role in that, and it's going to play a role in the throughput as well. Because if we have a lot of, it's not about painting the picture of the coverage is great, but we also have to kind of understand a little bit more about how that free space path loss is, how that signal leaves the AP, right? And moves along that path.
Exactly. So there's a lot of deep concepts portrayed in this slide. So I'm going to try to take it at a high level and kind of walk you guys through what's happening here. But the idea is if we imagine energy radiating out from an access point, as that energy propagates, the signal gets weaker and weaker and weaker just by covering a distance, right? So regardless of passing through any walls or bumping into any furniture, obstructions, anything in your environment, just by traveling a distance, that signal gets weaker and weaker and weaker, right? And if you wanted to generate this own graph via Excel or programmatically using a Python script or something like that, the equation that generates that script is on the slide there, and it's purely a function of distance and frequency, right? It has nothing to do with the antenna type, antenna model, the shape or direction. The rate of decay of that signal purely depends on distance and frequency, which are two factors that you see in that formula. And the other concept that you want to think about in this is something that we call the inverse square law. And the way I like to describe that is if you imagine a balloon filled with air, right? And you keep filling that balloon with more and more air, and its volume increases, right? So that balloon gets bigger and bigger and bigger, covering a larger area. And as it keeps expanding, the rubber or kind of the material of that balloon, it stretches and it gets thinner, right? So that surface area is being stretched over a greater and greater distance. So the inverse square law tells us that for every time we double the distance, every little surface area, if we represent that as 1 unit square, each surface area receives 1/4 of the energy every time we double the distance from the access point. So to put this more in numerical terms for Wi-Fi, if we happen to be standing 4 meters away from the access point, just as an example, we might hear a signal at neg 61 dB on the 6 gigahertz band, right? Or neg 61 dB. If we were to double that distance away from that, so to move from 4 to 8 meters, just doubling that distance, we would lose 6 dB of energy just from the change in distance alone because we double that distance and we move from 61 to 67 dB. And if we double the distance yet again to go from 8 to 16 meters, we now go from 67 dB to neg 73 dB, right? Now, this is one of the reasons, as a little aside here, I always I like to think about location tracking. You may have read a lot of literature for things like triangulation, that you want to hear 3 access points at neg 75 or better in order to accurately locate where that device is. Now, if you think through this, if we're standing at 16 meters and we double that distance yet again to 32 meters, at 6 gigahertz, our signal would drop from neg 73 to neg 79, right? And now we've kind of transitioned over that neg 75 threshold. And in that bin, we've gone from 16 meters to 32 meters, right? So our granularity, we're sort of within a 16-meter range of trying to identify where a device is. If we move all the way to the left-hand side of the graph, right, where change in distance from 1 meter to 2 meter also represents 6 dB. That little small distance there allows us to be quite accurate in figuring out where devices, high value assets, where people are on our floor plans, because a 6 dB change can be tied to a meter on the left-hand side, whereas a 6 dB change is tied to a 16-meter change on the right-hand side. right? And so that's one of the reasons that neg 75 is often the recommendation for location tracking. But that's kind of the concept behind free space path loss. Now, if we just jump to the next slide and we look at applying this into the model inside Ekahau, if we add a wall, what Ekahau is doing for us is it's modeling the free space path loss, the energy radiating out from the access point. And when you add a simulated wall, or if it, the signals hit the wall in your environment, they hit that wall, and that wall can cause them to reflect or refract or attenuate. But the point is that there's a net signal loss, and that signal's weaker on the other side of that wall. And once that signal passes through that material or object, we can just keep modeling the free space path loss as that energy continues and gets weaker and weaker and weaker until eventually it fades into the noise floor, right? And then it's no longer a usable or a signal that we need to worry about in terms of co-channel interference, right? But that's essentially what's happening inside the Ekahau model.
Well, it's always kind of it's really cool. I mean, just going back just to kind of the calculation in it, right? It's like we don't expect you to memorize this, but I mean, it's really cool that the actual math behind it, right? Is it makes it, how things leave and how that signal decays, and it's really super cool. But and the effort that it goes into kind of putting that into the actual software itself, right? So there's a lot of kind of a math and behind it, and can appreciate that. And thanks for kind of explaining that out, Troy, because you talk it all day long from a training perspective. So that was great. I love that. Thank you. I mean, when we talk about the RF as well, when it leaves the AP, right? And no two walls are alike, right? Because we have walls that are made of different materials. Some are more denser than others, and some behave completely different, right? So whether it looks like a standard wall, it may act like a elevator shaft, and it's not concrete. It's got other metal material in it, or it may have water, like a bookshelf. Believe it or not, bookshelves are contain water, really, because books actually are they have moisture in them, so they contain there is a bit of a water content, believe it or not. It's not like humans where we're bags of mostly water, right? But every wall, there's no two walls are alike. And that's going to get into kind of, and that's actually a good segue, I would say, Troy, just to kind of show kind of the overall what that actually looks like. So let's kind of, maybe we should spin over and to our AI Pro online here and kind of
Yeah.
show you a couple of new things. So let's do that. So um,
And
let's
with
share that.
drywall, it's a really wild material. Like you can have drywall that may be just one layer of thickness, but some buildings they're putting in two or three layers. You have that on both sides, right? So by default, Ekau represents a lot of different wall materials, right? But it's a really good idea for you to go on site and actually measure those walls. Confirm, is that material actually a 3 dB wall, or is it something closer to 5? Glass panes are very different as well. There's a lot of film that can be put in the glass, or metal that's melted in with the glass itself that helps it reflect the light to keep heat and things like that out. So especially glass panels on outside walls, they can be very high from an attenuation perspective, right? So it's always a good
I,
practice if you have the ability to go on site, measure those walls, and then you can use that measured data as part of your design to make it more accurate, make the model closer to the truth. Speaking of models, what do you have here to show us, Stu?
You're right. Yeah, it's like so. This is actually a mock-up we had for Cisco Live in San Diego just recently, and you can see this is actually you've got all the walls, with the floor plan of the entire World of Solutions, and right down to kind of the booth attenuations. And so our counterpart Matt has actually went ahead and got us all prepared for us, and hats off to him for getting this ready. But when we look at this, is like what does it look like from generally putting an access point in there, right? What does it look like to see from the attenuation? But let's take a look at these centers in here, these areas, these objects and booths that you can now create. So in this area here, from a wall perspective, Matt's actually kind of labeled out as a booth, and he's put in some height, he's put some attenuation in there, just to kind of give you an idea of what to expect and for certain things, and kind of maybe the attenuation, the denser areas. And you can see can get very creative in the types of furniture and whatnot. And the kind of the building template models, there's a number of them here that you can actually change. I'm in view mode, so it's not going to pull it down here at the moment, but there is a number of them that are available to you, right? So when we look at that we can get in from a three-dimensional view, and this is actually the fun part here, is that now you can actually see what it looks like with all of those walls in there. And we've got the objects and for the attenuation, the booths, and if there's any doors or, and as Troy's mentioned, any glass, not you'll be able to see that. So it's a lot of fun to kind of see it from a different perspective, and to have it be looking and excuse the kind of panning. It is very smooth on my end, but I think it's more of just me sharing it over the internet at the moment. But
It's that high
suffice to
quality
say,
hotel Wi-Fi.
right? Yes, it's exactly what that is. But remember those visualizations? Well, you can actually still look at them here, right? So what we were talking about earlier, and kind of the signal strength and secondary, and of course dominant AP as well. Obviously, I only have one on here, but it's just going to show kind of a red map. But you would go be able to look at the throughput type of map, and you can visualize that even in three-dimensional state, and you can see roughly where, okay, where is that going to land, right? Is that 120? And as you move along here, you can see it actually puts a little cell along there, and it gives you an idea of where it is on the map. And if you wanted to get a little bit more some fun with it, you can even actually drop down an inspection tool within there to see that as well. We'll talk a little bit more about that in a moment. But that's just a little bit of a key little thing of the capabilities that we're to actually be able to do here. All right. So we'll come back to that because I'll switch in mode a little bit after. How about we do that, Troy? So hang on, that there. Get back in. So when we talked about kind of those signal strength and whatnot, we want to kind of cover a few things from a perspective of there you go, from the walls, is kind of those reflections, right? So the bouncing of signals. So occurs when you have that RF reflex when occurs when Wi-Fi signals encounter surfaces that can't penetrate, and it's causing that wave to kind of bounce back, right, or change direction. And most common reflective surfaces, like as Troy was mentioning, kind of the glass and whatnot, is how it reflects and it bounces around. But some of the reflection piece, it changes a little bit when you have more of that ripple effect, and you get in kind of the diffractions. Now, both of the reflections and the diffractions. Now, and we'll cover this is where the diffraction is just like that wave is bending. It's getting stuck by an obstacle. It's moving around. It's trying to get around that edge, right? Big piece of furniture or a column. Now, why is it important that I'm talking about this? Well, the reason we wanted to kind of home in on this is because we actually take into those calculations live within AI Pro Online, and where we in the past we were it was a feature to turn on, but we thought it was really important now for our customers to understand is that you're out there designing it, you want to be able to kind of understand that propagation model without what it looks like without, but also with the diffraction. And it helps better from a planning perspective.
I've always thought that surfers would make better Wi-Fi designers. And whenever I think about diffraction, I always like to think of the movie Point Break, and imagine the waves out when they hit a sandbar.
Yes.
Those waves will bend around that sandbar coming in towards the shore, giving you a great surf to catch, right? So diffractions are really interesting in a lot of your designs. Right? In the image that you see on the screen here, you could have a shadow that could be an artifact of there being a pillar or a column, some sort of machine equipment, but it's a significant structure that's fairly large. And if you imagine standing on one side of a pillar, if you were to shine a flashlight at that pillar, on the back side of it, you'd have a shadow, right? There'd be less light behind that pillar. That's essentially what you're seeing on the left-hand side in that image, right? There's an RF shadow, right? Because the RF energy is radiating out from the access point. It's being blocked, obstructed by that pillar, and it can't get to the backside, right? And that's the way a lot of traditional modeling would display this and render it and show you your heat maps. But in reality, what's happening is we have phenomenons like reflections and refractions and diffractions, and there's a whole bunch of wave bending going on. It's almost like I also think of the movie Bend It Like Beckham. I got a lot of movies on my mind tonight, thinking about these things. Every time I see the word bending, I keep thinking wave bender. Right. But when we start including that modeling inside the signal heat maps, we can then model those signals that accurately wrap around an object. So one of the ways that I like to think about this is if you have an object like a big concrete column or pillar in your buildings, if you can hug that column, if you can wrap your arms around it and give that column a big hug, the RF waves have a good chance that they'll bend and wrap around and fill in that shadow, which is what we see on the right-hand side. So with the diffractions enabled, and these are screenshots from the desktop version, AI Pro Desktop, where we have the ability to turn on and off the fractions. In the AI Pro Online version, it's enabled for you all the time, right? So we're modeling something, as Stu mentioned, that's always more real world accurate. But here we're able to show you those differences. And with that small object that you'd be able to wrap your arms around, the RF energy fills in that shadow, creating coverage that you'd expect or that you want to provide for your users. Now, if we were to place that access point pressed right up against the column, right, butted up right against it, then you would still have a shadow because we haven't given enough room for the waves to bend and wrap around that object. It just pressed in there too tight, right? So that wouldn't be a good practice to stuff a access point right against the column. You'd want to move it, several meters away from that column just for this phenomenon to take effect and wrap around it, right? But always think about surfing. Again, I think it makes us better designers. And it's a good way to think about diffractions, bending, wrapping around sandbars coming into the coast, or like you see on the previous slide, the waves wrapping around the rock that was in the slide, right? So again, to emphasize, in AI Pro Online, reflections and diffractions are modeled all the time by default for you, right? So it's just a feature that's always enabled, making it more accurate in your heat map displays.
Actually, yeah, really good stuff there. So we talk about a little bit, and we'll touch on a couple of comments there. And I see some things in the chat there, and want to kind of see how that we would define warehouse racks and whatnot. And that's a really good point, and sorry. And what we'll do is we'll cover that towards the end in a little bit more of a demo. We'll mock up an attenuation area to kind of show you what that looks like. So definitely that is definitely doable. All right. So from a primary coverage perspective, we look at, kind of the signal strength of the strongest AP, right? So when we're placing those access points and we're going to look at, how does that look at from an overall performance piece, right? So we have, here are some AP1, AP2, AP3. And where we're deciding is where does that primary and secondary coverage come into play? Because it's important that we know that, okay, the closer we are to 1 AP and where the sidekick is closer to AP2, it is going to be neg 59. And that is the primary piece. And that's most likely with the client. If the client was right beside me, it's gonna latch onto. Now it's going to want to hear that minimum level of 67, 68, that sweet spot. Yes, that's going to be my secondary AP. And so it's going to make a choice. And then from a third perspective, or I guess should say, Troy, I think we used to always call it the tertiary, but it was more of just like, that's that next AP, right? We would use that in our RTLS planning days or location analysis, right? So that's when we really get into that part. But it is important that if you as you're moving along, you've got that kind of area to make sure you've got enough coverage within that. And what it looks like from a secondary coverage, you'll see that, right? Is so if I go back from the primary to the secondary, is that AP1 is going to be my secondary piece, right? And so that's where it's like, I'm going to latch onto that one. But in order for that to happen, always a rule is the client's going to make the decision to roll. Now, in some cases, some AP vendors can influence that decision, but it's not as hard, it's not as easy as it may look. But as we get into other technologies like Wi-Fi 7 and Wi-Fi 8, that starts to become a more reality of how we can actually make that goal attainable, right? But it is still important that when you're placing access points, is that you've got the right area in there. And when you have those building blocks in place, it's going to make a significant piece to help you on from a capacity planning. You wonder, so, well, why do I need to make sure that like a good primary and secondary signal strength from capacity? Well, you're going to want to make sure that from a capacity is that do you have enough coverage to offload? Because there's going to be times when I think, Troy, it's like when you're designing an office, you look at it, it's like the full floor plan, like the Helsinki office here, and you're like, I think we're going to need two in that area where it's labeled right in the dead center there, because you're going to want to make sure that you've balanced it out in a way. It's like think about like the lighting or air conditioning. You want to make sure that you've got enough cooling to balance out that area so that clients be will be happy.
Yeah, capacity is a wild conversation. And as we mentioned earlier, it's one of the most important factors you want to include working on a design today. And again, you can look at it from two different perspectives, right? There's just the throughput that you're trying to achieve per device, as well as the ratio of devices per access point, right? So if we look at the latter just for a moment, devices per AP, it's one of those numbers, you ask 10 Wi-Fi practitioners, how many clients should connect to a given radio. Ask 10 of them, you'll get 12 different answers, right? Everyone comes up with their own scheme. And it depends on the environment, right? What may be a valid number for a stadium, uh, a high density environment like that could be very different than what you'd find at a convention center or a hotel or a school or just a carpeted office enterprise versus a warehouse, right? So often to those types of questions, I always like to throw out the number 42, right? Which is a wild card answer. If again, I've movies on the brain tonight. I just can't help myself. If you've ever watched the Hitchhiker's Guide to the Galaxy, you know that 42 is the answer to life, the universe, and everything. Well, if you look up 42 in an ASCII table or an ASCII chart, 42 is the asterisk character. It's the wild card, right? And basically that means that 42 can be whatever you want it to be, right? It's the I can be anything answer, right? So as a cheeky response to, how many clients can connect to a radio or what's the design threshold that we should use for capacity number, I often say 42 until I start asking more questions about how many devices will show up on site, what's the nature of the facility, how dense will the people be? All right, so earlier we showed you the floor plan from the Cisco Live World of Solutions floor in San Diego that they just held. It was just last week. Wow, it feels like it's been a month ago already. It's just been a few days. But they have a little network operations center, and Cisco shows off how many devices are connected to the network, how much traffic they're passing, how many client devices are connected on Wi-Fi 7, Wi-Fi 6, Wi-Fi 5, so on and so forth. But one of the key metrics that I always like to look at is what is the maximum number of devices connected on the Wi-Fi network. I always want to see peak device count. And I also like to take a look at what are the number of registered users, right? So this year at Cisco Live, there were, just over 20,000, a little above that 20,000 registered attendees. But the peak client count the max that I saw was 17,000, right? So 17,000 devices, which meant in a conference full of geeks, the people that you think would stress out a network, we barely achieved a one-to-one ratio of devices per user. Right now, if we'd fallen into the trap of assuming that, everyone brings in 4 devices per person, and then we had the people who designed that wireless network design for 4 devices per person, it would have been radically over-engineered, right? Because we just didn't hit those thresholds. So there's so many traps that you can fall into when you start generating some simple capacity models of assuming that there's just too many devices in your environment. Now that's 17,000 devices versus 20,000 or so registered attendees. That doesn't mean that everyone connected just one device. Some people did connect 4, but that also means some people didn't connect any. Maybe they wanted to turn themselves off from the office for the week. They just wanted to focus on their sessions or playing capture the flag or something like that. Other people, maybe they didn't trust the Wi-Fi network. They wanted to connect to cellular, right? So you still may have users that are using multiple devices, but on average, across that large volume of people, we still saw just a one device per person ratio, right? So keep that in mind as you go through these capacity planning exercises, that you can really run into a trap and start adding way more access points than are necessary to try solve a problem that doesn't really exist, right? And then as you add all those extra access points, you end up accidentally creating co-channel interference problems. And now you're trying to manage your channel distribution and allocation across your access points. You're trying to play with your channel width, determine, can I do 80, 40, or 20 megahertz wide channels on 5 gigahertz? Right, depending what regulatory domain you fall into, you may be able to take advantage of the full 1200 megahertz in 6 gigahertz, or you're more confined to just be able to use the lower 500 megahertz. But that'll help guide you to whether or not you want to use 80 or 40 megahertz, or maybe you have to use 20 megahertz channels just to avoid all that co-channel interference, right? Other ways to think about capacity planning is, again, with the number of devices connecting to your network, you may come up with a threshold. You want to focus on, of all the client devices that'll be present in my environment, how many will actually be active on the Wi-Fi network, right? So I'm not talking about just associated and idle. How many will actively be transmitting data, right? So maybe it's 60% or 75% of the total users. Sometimes I like to make it 50%, so the math is a little bit easier in my head. But of all the clients that are there, if only half of them are active, if we were designing for a stadium, right, so super high density type deployment, you could have access points. If we look at a Cisco AP as an example, it might have a sweet spot that it can handle 75 active associations, right? It can handle, or 75 active users rather. It can handle definitely many, many more associations, but 75 active users is sort of where they say, hey, that's probably where you want to, regulate your design. Now, that's 75 active users. If half of them are idle, that means we could have 150 devices connected to any given radio with only half active at any given moment, right? So we could have an access point way up in the ceiling, shooting down, lighting up a section, or maybe we've gone with an under seat design. We have an AP below the seats, lighting up a small section. But that one radio could be responsible for connectivity for upwards of 120 clients if we assumed a 50% active model, right? Now, different venues will have different levels of activity. We have also seen some sporting events that change based on the game that's being played, right? So basketball versus baseball versus proper football, right? Cricket, whatever. Like there's different usage patterns as things change in the game. And sometimes based on the Wi-Fi patterns, we can actually predict based on models what sport is being played, right? So it becomes very interesting from that perspective. Right? And we have the visualizations within Ekahau that allows us to see when you start placing access points on your floor plans, you can then set thresholds for how many clients do you want to limit per radio, right? On the 2, 4, 5, or 6 gigahertz band. Right? And make sure that you're still compliant. And if you're not, you have the ability then to start adding access points into that design, while always checking back to make sure that while you add those access points, you're not accidentally breaking co-channel interference within your models, right? Which again ties into the fact that one heat map on its own won't give you your complete design or your complete analysis. You need to look at how all the heat maps relate to each other as part of a collective set of information and visibility into your Wi-Fi project that you're working on.
Yeah, that's a great segue into kind of that how do we look at that from a perspective of design. So right now you kind of see is that new feature for the inspect tool we have in AI Pro Online, and that really plays that role of understanding where the thresholds are met from a capacity perspective and primary and secondary signal strength, and really helps you out from a design perspective. And it's a really good learning module for it. I'm going to go ahead and bring up the actual AI Pro Online here so we can actually have some fun with it. I'm going to start with a fresh one here for us. And it should be, there we go. This is actually kind of the same map, but what you could do here is if we were to kind of place walls in place, well, I can actually even do this. I can actually let the thing do it for me if I wanted to. Uh, it'll actually build out some walls, but if I was to build kind of the booths and things around it, it can definitely do that for me. So if I wanted to start, I'm not going to let it do the whole thing. I just canceled it here, but it's going to place some walls in here for me just to have some fun. But if I was to say, okay, well, let's build up a min attenuation object like we did earlier. Let's put that in place, and we'll just draw a box here quickly. And all right. And oh, hang on, I did not click. I don't have my mouse with me today. There we go. There we go. Then you can actually change it, right? So remember we talked about earlier is you can add different materials and different attenuation objects, and you can do that. We're going to add a few more of them in here, of course, but you can always add your own custom one. There's a few actually one in here. There's some that are actually that I'll see if we can get put back in here is actually the foliage and some outdoor stuff because they can become helpful. And even in today's buildings, there's even lots like indoor parks, right? There's like indoor
Absolutely.
trees, right? And buildings, even cruise ships have that down there, kind of little central park areas. And so that it's not really outside, but it's inside. But it does have a different factor to it. So you could actually draw something. So if I really wanted to draw, like, say this was a tree, I could then do, something like this and draw the kind of the tree around it, right? And do that. Or if I was long, make sure I can draw my polygons here properly. And there we go. And I could say that that be a tree, and then I can adjust the height of that tree as well, and kind of the footprint of it. So that would be something that you could do. But then when you're placing access points, as Troy's mentioning before, is that if you have a kind of the generic access point here, I think we even have the standard Ekahau one. There we go. Got our Ekahau APs, and we'll put that in place. But as we put an actual place AP in here, and we have some objects, and there's that reflection and diffractions in action, right? It's like showing you what it looks like as you place that around. And you're going to go ahead and place another access point in another specific area and whatnot. And this is where it then becomes that inspection tool. It's like, okay, where are we on this map? And where's my primary and secondary? Now, this is a great distance. Now, understand that I didn't put all the rest of the objects in here. And if I did, then that would start to change up the data itself, the calculations are going to get changed quite a bit. So as I put more, or if I even change the structure, instead of a 3D 310, I could change it down to like a warehouse rack that we were talking about earlier. And then what are the height? I can change it. Maybe it's going to be. I know we're in. It's showing it here in units here. But we're going to go. So let's say it's 30 feet high, right? And is it distance from the floor? Is there a height between it? Now we're seeing how these points themselves are going to show around those areas. And it gives you kind of more of an understanding of the planning. There's that shadowing, right? Troy is like that. We're talking about those reflections and
Yep.
diffractions, but this is the real stuff, right? And where APs are. Now, if you start placing these APs at different heights, then it comes into that calculation as well. Well, now we have to change that. Is that a wall mount? Is it ceiling mounted? Is it directional? And this is where you can actually change that. Obviously, this isn't when I put it on, but if I'll change it to like, 30 feet, and then I would actually have a kind of a down tilt, right, to that. So now you can see where I can actually place the antenna, and does it make a difference? How does it project in there? So there's a lot of cool things, to ways you can look at the visualization of the height of the device. So that the you're at 3 foot level, the AP is at 30. Well, this is what you're going to see from that in the inspection piece.
And that inspection tool is really powerful. I think that if you drag it across your floor plan and mimic the path that a person would take to walk, is if they're walking from their office to the kitchen area, or from the stands to the concession area, but follow the path that person makes, and then see which APs they're going to connect to. Are they going to roam in natural roaming spots or locations that you think could be beneficial to the roam? Would they hang on to access points? Would they roam too early? But by using that inspect tool, you can simulate or mimic the path that your users will take through your environment and just double check to make sure that there's going to be the roaming that you expect as part of your design. And if there isn't, this gives you a chance now to reposition your access points, modify your antennas, adjust your tilt, like Stu was explaining, but you can change your design. That's one of the things I really like to use this inspect tool for, is just validating that if I pretend I'm the person walking through my environment, what will my experience be like?
Yeah, absolutely. And if it's and it gets even more fun, not from a design perspective, but let's say that you went in and said, well, I need to look at it from an actual, right? And what does it look like from an actual measured environment? How does that what does that look like? And those are things that we can do, right? We can show that. And that actually really shows where the gap is, right? If from a roaming perspective, and also looking from that calculation of capacity. So I'll bring up another quick one here just so we can see it. And this is actually a real environment. It shows you the power of like the data you can get from the Sidekick, but then it'll say, okay, well, what was the actual from those access points, right? And then it'll put that in place. There we go. Excellent. So in here, I've got a number of devices in here, and I'm going to go and reset it to the old one. So let's go ahead. I was doing some fun, and that's actually a cool thing. We'll touch on this in a second. Is you can actually look at a greenfield design and then replace it, right? So let's go ahead, and I'm going to restore those devices. Now this is the actual. So this is actually all measured data, and you can actually see that there's a floor plan here. There was a survey that was done. You can see where all the APs are actually behaving, how they're working themselves around all the offices and all these attenuation objects. But what gets really cool is when you look at that let's move this column over here. Get this away. Hang on. Let me just move this off here. Oh, I think my screen has shrunk a little bit. I can't move that off. Can't close that window. There we go. So now if we go from an inspect tool, and as Troy was mentioning, if I'm walking in this area, and I'm just going to turn the signal strength off here just for a second because I don't necessarily need to see that. So I'll just turn that off for a minute here from the heat map. But take a look at where it gets really interesting is I'm a person and I'm walking from this door. Typically what's going to happen is that while I'm standing here, I'm hearing all these APs. I'm hearing AP number 12, 2, 1, 3, and 4. And these are the signal strengths that it's hearing it. And you can see it all in the list of the columns. What's important here is that as I'm moving with this in this environment, I'm connected to that AP. And it shows you you're connected to AP2. That's your primary, right? So it's showing that there. Get in here. Showing that right in there. And as I move along in that walking path, and keep going across, it shows that, okay, where's the next one? Secondary. And when is it going to roam? So there's going to be a point where it's going to go, okay, you're now roaming. So I get over there, and then it's roamed. And you'll see that it's highlighted right there. Go back a bit. See, this is roaming. So at neg 48, 17 feet, that's generally what the roam is going to happen in there. And so it's a very powerful tool, and it's all based on the Sidekick data. But when you survey, I surveyed every little nook and cranny in here. Wherever people are going to use Wi-Fi, that's where you survey. That's where you grab your data. And this is how powerful it is to grab all of this to understand where things will lie from that perspective. Now you've done that quick survey, and you know, like, oh, you know what, we're gonna need to kind of maybe we're gonna upgrade our access points. We want to kind of do that. We may even want to look at offsets as well, for the type of devices we want to use. But let's go ahead and say we want to change those APs out. We certainly can. All we do is like, hey, we're going to retire these older MR 34s, I believe it is, and we're going to put in some cool 91 70. Let's do the 72s here, Cisco, and I'm going to go into the 91 70. Is it 91 78? Because that's fun. So now with just I've done it. That's it. All done. Now that
And
I've got
this
my
is fantastic for those scenarios where you want to reuse your existing cable drops. You don't want to incur the
Mhm.
cost of running new cables. Maybe it's too expensive, cost prohibitive, for aesthetics reasons, whatever it is. But if you wanted to just see what a one-for-one swap would look like, that's exactly what Stu is demoing for you right here, where you can swap those APs out, use the exact same drops, and confirm with that new model, that new refresh, are you going to get the coverage that you expect?
Yeah, and it changed the channels right away. So it took a second to as I placed the APs, and then it went through and started massaging the channels and understanding what was to be expected for this environment based on that Sidekick measure data. That's where you get into our secondary signal strength, our channel interference, dominant APs, right? That we got to talk about earlier, whether it's in 2.4, 5, or 6, and then our throughput as well. Now, if we wanted to go back and take a look at it from the incumbent APs that are in there, do I have good signal strength in the secondary? I may have. Did I have channel interference? I certainly did. So this network can use some help in optimizing. Yes, we got a button for that. We can go ahead and optimize just the channels themselves, and we can resolve that to kind of help while in the meantime, while we're in the middle of an upgrade. Let's give it a helping hand. Maybe it's just we need to turn some nerd knobs on the dashboard and or the controller just to kind of get us going while we're waiting to transition. So a lot of times it's not always the environment. Sometimes it's just the environment at which the APs are in. They've made a poor decision on channels and power, and this is where the tools can really excel and take you up to that next level.
Yeah, so inside Ekahau, we're proving that there's a valid channel plan that you can use. If we can get it to work in Ekahau, we can mirror that configuration in your Wi-Fi manufacturer's controller or their management dashboard and set them up for success, right? But if we can't eliminate co-channel interference inside Ekahau, mirroring that configuration in your Wi-Fi network is going to cause and contribute to co-channel interference, right? So we're just proving that we have a valid, successful design, and then just mirror that configuration for you as you go to deploy.
Yeah, and I mean, and this is now that even that next step is that, well, we've got all this, maybe that we want to see, maybe we already have a network that we've measured, or maybe we've designed, but maybe we want to connect to a live network. Well, we've got a button for that now. So in this case, we've detected that we have a Cisco Meraki dashboard or a Cisco, I guess you now can call it Catalyst Center. We can now connect that live network. Now today, all you need to do is it'll grab the data and we can proceed. It'll connect through an API. All you need to do is put your API key in for your dashboard and the region and hit next. And what it'll do, it'll actually the live cloud data from what the APs are configured on right away. So you can actually make a decision and the system will tell you, you know what, the dashboard currently has all of these APs set for this channel. This is what we probably, based on the data we're seeing here, we might want to change that up. And so that's where you get that extra helping hand and from the dashboard. And so we're going to be making those tools available to other dashboards as well soon enough throughout the year. But it's important to note that we've got this live today, and you can use it. And I encourage you to try it out and have some fun with it. You'd be surprised of some of the cool stuff you can get back from your access points. All right. Well, I think that we're just wrapping up here on about a minute to go here, minute and a half to go here, Troy. But I think we pretty much covered some of the cool stuff that we did from a design perspective.
As we wrap up here, I just want to remind everyone that's still in the call, we have published the ultimate guide to deploying Wi-Fi 7 technology. So if you haven't already, feel free to scan this QR code. Feel free to check it out. It's a very detailed, very descriptive guide that walks you through the process of the considerations that you should think about as you start selecting new access points, evaluating your client capabilities, look at scale and capacity. Also things that you could think about in terms of running new cabling and providing enough PoE for your switches. A lot of the new modern Wi-Fi 7 access points are very power hungry, and you want to make sure that you have sufficient PoE budget so that you can power all the radios on all those access points. Sometimes they're tri or quad band radios with IoT, multiple IoT radios and USB ports as well. All right. And with that, I'd like to thank everyone for attending the webinar today. It's been a great pleasure hanging out with all of you. And as always, if you want to request a demo with Ekahau, feel free to hit up ekahau.com/demo. All right. Anna, is there anything that you wanted to add just as we wrap off here?
No, it was a great webinar overall. I think everyone is that was very insightful. Everyone was pretty excited about all of all of the stuffs that we've talked about. So just one last thing that I saw in the chat that they're asking for that Wi-Fi 7 guide. So I'll have to have the team send that to you via emails so you don't have to worry about it. So yes, thank you everyone. Thank you, Troy, for joining us for the Ekahau APAC webinar. And yes, I hope everyone enjoyed their time with the webinar. Thank you so much.
Thanks, everyone. Until next time.
Thank you.